There are two main types of waves. One is longitudinal, which is when the movement of the particles are parallel to the motion of the energy. Sound waves moving through the air is an example of this type of wave. As you can see, this is an example of a longitudinal wave. This part is compressed and that part is expanded. The disturbance direction for a longitudinal wave goes back and forth. Air molecules are moving kind of like our example here. Sound waves travel in the air, which is caused by air molecules bumping into each other. Because the tennis balls are so close together, and the air molecules are also close together, that's how the sound travels. Another type of wave is a transverse wave, which is when the movement of the particles are at right angles, perpendicular to the motion of the energy. Movement of a wave through a solid object, like a stretched rope or a trampoline, is an example of this type of wave. Here is an example of a transverse wave. As you can see, that is the amplitude. The crest is the highest point above the equilibrium position, and the trough is the lowest point below the equilibrium. Lambda, or the wavelength, is the distance between 2 points in the wave. So the formula is v, which is the speed, equals f, which is the frequency, times lambda, or the wavelength. The disturbance direction for a transverse wave is both horizontal and perpendicular. Ripple waves in a pond start with a disturbance at some point in the water. The disturbance causes water on the surface near that point to move, which in turn causes points farther away to move. In this way, the waves travel outward in a circular pattern away from the original disturbance.